So in this video what we're going to do is look at calculations involving masses using the concept of the mole. So one of the things we know in chemistry is that the molar mass, the number in the sum of the ARs in the periodic table, is the mass of 1 mole. So if we know that that is the mass of 1 mole of it and we've got 2 moles, then to find the mass of that amount we would double it. So mass is number of moles times mR. Now if it helps, you can remember a little phrase that mass is Mr. Moles. And if you remember Mr. Moles, that's going to remind you how to create this triangle. Now the symbol for moles in chemistry is not an M because that's mass. The symbol for moles is N, number of moles. Okay, so we have an N for moles. So we can remember that mass is Mr. mR times moles. And this mass must be in grams. It has to be in the unit grams. If it's not in grams, we're going to need to convert it. So see if you can use those expressions to answer these two questions. You will have done something like this at GCSE, so you should be fairly familiar with it. So if you had to go at those two questions, you should have got 2 moles and 80 grams. Now the unit of mole is to write mol at the end of it, so we've got 2 moles. If you didn't give a unit, you would still get it marked correctly because it's number of moles, it's a number. We had to work out our 2 MRs, so if you made a mistake in your MRs and that's led to the wrong answer, just check your MRs. Now we do need to be careful to use this calculation. Our masses must be in grams. So we need to think, if our mass is in milligrams, remember milligrams are very small, and I need to convert it into grams, then I'm going to have to times 10 to the minus 3 because there are a lot less grams than there are milligrams. If I know a number in grams and I want it in milligrams, then I'm going to end up making it 1,000 times bigger because there's a lot of milligrams in a gram, there's 1,000. If I want it in kilograms, then I would go minus 3 from grams to kilograms, but if I've been given it in kilograms, it will be times 10 to the plus 3. And if I want it in tons, squeeze tons in there, again it's another factor of 1,000. So if I was given a number in tons and I wanted it in grams, I would be doing times 10 to the 6 because I'd be going 1,000 and 1,000, so it's 1,000,000 times. So we just need to be able to convert between these units. So bearing that in mind and thinking about the formulas of things, see if you can answer these 3. So for our first one, the first little trick we don't want to fall into, again from the introduction to chemistry, remember those diatomic elements. Iodine is actually I2, it's one of the diatomic elements, and so the MR is not just the number in the periodic table, it's 253.8. And then we've got milligrams to grams, we're needing to convert milligrams to grams, so we've got our conversion factor here, and we've worked out our number of moles. And in our next example, again, we've got a conversion factor from kilograms into grams. This time we're making the number bigger. And one of the little tricks that I would always use is I would like to put N in bracket and then in brackets say what I'm calculating moles of. Because in an exam in chemistry you might be calculating moles of 2 or 3 things in the same question. It helps you later on to identify things if you label them clearly. So on that last one we've got our conversion factor again. So remember we're going from tons this time, so we've actually gone times 10 to the 6. There's 1,000,000 grams in a ton, and I've given my answer there. But what if I asked you, could you convert that to 3 significant figures? So to 3 significant figures, there's 1, 2, 3. I'm going to round up 19,980 to 20,000 moles to 3 significant figures.